In the previous lesson, the x and the y coordinates of the viewBox were set to 0. And that means that the viewBox started at the origin point of the local coordinate system. We can see the shark in the browser window. If we look at the code, we will see that we haven't set the viewBox. And that means that the size of the viewBox is equal to the size of the viewport. And the viewBox starts at the origin point of the local coordinate system. If we'll add the viewBox attribute with the same parameters as the viewBox geometry property have, nothing will change. And now, let's change the coordinates of the top left point of the viewBox by changing the min x and min y parameters in the list of viewBox values. But where did the dolphin came from? The dolphin has been already drawn in the local coordinate system layer. It was outside the viewBox boundaries, and therefore it was invisible. After we've changed the value of the min x and min y parameters, the viewBox shifted to the left. We can consider this shift as an applying transform translate function to the viewBox. We can look at the min x and min y values as on the parameters of the translate function. Then, the user agent binds the local coordinate system layer with the viewBox layer. If the size of the viewBox and the size of the viewport are equal, then the transform translate function will be running again. The bound layers will move to the area where the viewport is. The transform translate function joins the bound layers with the viewBox layer. So, we have considered the case when the size of the viewBox and the size of the viewport are equal. But what if the size of the viewBox is larger or smaller than the viewport but have the same aspect ratio? If the viewBox is larger than the viewport, the user agent proportionally decreases the size of the viewBox and the size of the local coordinate system with its content. The user agent decreases the viewBox until it completely fits into the viewport. If the viewBox is smaller than the viewport, the user agent will increase the size of the viewBox and the size of the local coordinate system with its content, until the viewBox completely fits into the viewport. We could consider this process as applying transform scale function to our bound layers. Know that the units of the local coordinate system and its content also change, as if they have been multiplied on a scale coefficient. The scale coefficient is a scale function parameter. The scale coefficient is the proportion between the width of the viewBox and the width of the viewport. The same is true for height. So, in this lesson, we have learned that the viewBox can differ from the viewport at its size and its position. We have also learned that to bind the viewBox layer with the local coordinate system layer, the user agent uses the transform translate function. We have learned that the user agent uses the transform translate function again to connect the viewport layer with the bound layers. To fit the viewBox inside the viewport, the user agent applies transform scale function with the scale coefficient as a parameter. In the next lesson, we will learn about more complicated cases, when the aspect ratio of the viewBox and the aspect ratio of the viewport will differ. We will learn how, when, and why you should use the preserve aspect ratio attribute. And that's all for now. There is no homework assignment in this lesson. I will see you in the next lesson.